Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 72, and we're given the structure and we're asked to rank the labeled protons A to E in order of increasing acidity and explain in detail the order of your choice. So remember, in order to determine which proton is the most acidic, the more acidic the proton is, the more stable the conjugate base must be. And we have three ways of stabilizing conjugate base. Number one, putting a negative charge on an electronegative atom such as oxygen. Number two, resonance stabilizing the conjugate base such that the negative charge is going to move within the molecule through resonance stabilization. And number three, inductively stabilizing the negative charge through electron withdrawing effects of electron withdrawing groups or electronegative groups in proximity to the negative charge in your molecule. So let's look at this molecule. Right off the bat, we can see that we have two carboxylic acids, HA and HE. So right off the bat, we can say that these two protons must be the two most acidic protons. But which one is going to be most acidic? Well, both of them, once deprotonated, put a negative charge on each oxygen atom, so that's a tie. Both of them will go through resonance stabilization through the carboxyl group, the carbonyl oxygen, so that's a tie. Now, what about inductive stabilization? So we see that we have an alcohol group here. This alcohol group is one carbon away from HA. However, the alcohol group is 2 carbons away from HE. So because the alcohol group is closer to HA than HE, HA will have a stronger inductive stabilization effect due to the alcohol group than HA, therefore making HA the most acidic proton on this molecule, followed by HE. Now, what about the next most acidic? Well, we have HB, C, and D. HB is from an alcohol, HC and D are from carbon. So obviously we can say that if we deprotonate HB, we'll have a negative charge on oxygen, which is electronegative. However, if we deprotonate HC and D, we'll have a negative charge on carbon, which is not electronegative. Therefore, deprotonating HB is more favorable than deprotonating HC and D, which gives us HB next. Now, what about C and D? So both of these, once deprotonated, will put a negative charge on carbon, which is not that favorable. You can't do any resonance with them because they're not attached to any sp2 hybridized carbon. And so the only thing that would be left would be the inductive effect, so the proximity to your electron withdrawing alcohol group. So your electron withdrawing alcohol group, so HC, is directly bounded to the carbon that's also bounded to the alcohol, which is also adjacent to the carboxylic acid. So you have 2 electron withdrawing effects occurring here from these 2 substituents. However, HD is adjacent to this alcohol and is also adjacent to the carboxylic acid. So because HD is further away to this alcohol than HC is, HC must be more acidic than HD. So HC will come next, lastly followed by HD, which is not directly bounded to the same carbon that has the alcohol group, which is HC.